programming language for data analysis. If you are interested in becoming a renowned data scientist, then R is the tool to use. In this video, we are going to look at the basics of R and how to maneuver around it. So what is R? R is a software package for statistical computing and graphics. It has a collection of over 18,701 packages. It is widely used since it is a powerful tool for analysis. Again, R is free. You can easily find it on website. You download it and install it, and there you are. Now you can see here, these are the packages that we have. Over the years, people have developed various packages, and you can see right from 2002 all the way to 2014. That is how this graph has captured it. But now, currently, up to this year, we have more than 18,000 packages. Now, if we can go to some history about R. R was based on S, which was coded in C software. S was developed at Bell Labs starting in the early 1970s. R was created in the 1990s by Rose Ihika and Robert Gentleman. S largely was used to make good graphs. Not an easy thing then, around 1975. But R, just like S, is quite good for graphing. Now you can see these are some of the plots developed by a package in R that we refer to as the ggplot2 package. You can see we have a graph here. We also have some bar charts, some histograms here. Now again, it can be able to do some more complex proteins, including the box plot, and again even telling you the threads around various items, including correlation between one variable and another. Now, the users of R, now me being one of them, we have other many users of R, including people interested in data mining, people using other statistical softwares, including SAS, including SQL, including SPSS, Python, among others. So this is just a snapshot of the many users that we have for our program. Now you can see the trend of jobs. So now over the years, you can see that many more people have joined the league of data scientists. And so over the years, you can see the trend. It has been increasing, the percentage of people or jobs in the area of data science, and again for those in other complex fields, say the machine learning and deep learning. Now again, RStudio, which is an integrated development environment under R. So this again runs under R, and this is actually what we are going to focus our lesson today on, the RStudio. So this is somewhat a gift because it makes it easier to use R, the base R. So instead of using the base R, we use the RStudio. Again, we note that this is also free. You can easily get it from the website, the RStudio. You just download and there you go. You're able to work with this. Now, this is how the RStudio looks like. It has various frames, and from this you can be able to write your code, and you can be able to write your code here. You get your results. These are some of the items that you've saved. Say if you've given a name to a certain data, it will show here. Then this is the output of the graphs. So this is how you're able to visualize your data around this point. So these are the results of the code. Then on this part we have the graphs. Now right away, how do we now get this R and the RStudio in our computers? So you can just download it. So if you go to the www.r-project.org, you're able to get the base R into your computer. So you just download and install. Again, so you first download the base R to your computer, install it. Then you again go ahead and download the RStudio into your computer. Once you download it, again now you save and install it. Now, depending on the OS that you're using, possibly you are a person who uses the Linux system, there is another one who uses the Mac OS, and the others who use Windows. So you can easily be able to do or to run your codes in either of the systems that you're using, the operating systems that you're using. Now, what I'm saying is that if you go to your website or your browser, you can easily search for R program, the R programming software. Then you can see here you're going to get the latest version of R. So once you click here, it is going to download. Then you can install this software in your computer. Again, after you install this, you again go back and search for RStudio software. Again, it you open, then you can click on the first link. Once you click on the first link, it's again going to take you to the RStudio website. So here you can see it's talking about you being able to level up your data science training with RStudio Academy, but we are not interested with that. So our interest is being able to get the RStudio into our computers. So what do you do? How do you do that? Now here you again get to you say get started. Once you say get started, now check what is available here. So our interest is to download the RStudio into our computers. So you can be able to read all this so that before you can get started, you are able to know what exactly RStudio will do, how you can be easily search anything from this website to be able to know how various companies or various institutions are using the RStudio. Now once you are there, you can see we have here around this point we have download. So once you click on that download, then it will take you now to a page where you can choose which software or which version of the RStudio that you're interested with. And so at this point I'll suggest that you select the RStudio free. So this one, it's going to have all the packages that you need to work as a data analyst or a data scientist. You can see that it has integrated tools for R, And so once you download, it is going to download and save in your computer, and then from that point you can easily install it, and then from there you can now start running your RStudio. Now again, now open your RStudio. Once you open your RStudio, now this is what you're going to get. So this is what I'll say. So here you write your codes. Down here you get the code and the output or the result. Around this point you get the graphs. Now, and at this point you get your data or your objects or items that you'll be saving from time to time. Now we've said that RStudio, or basically R, is a very powerful tool such that you can easily use it as a calculator. One of the basic things that RStudio can do is you can easily use it as a calculator. Say for example, you want to add two numbers, say 4 plus 4. So you can highlight this 4 plus 4. Then around this point you can see here, run the current line or selection. So once you click it, it's going to give you the code down here and the answer. So 4 plus 4, we know that it is 8. Again, if you wanted to do 4 times 5, so 4, you select the asterisk and then 5. Then once at that point you highlight, then click run. So you can see that that is 20. Again, you can do this. You can take, if you want to subtract, you can take 20 minus 11. So it doesn't really matter whether this is highlighted or not, but once the cursor is on that line, we talk of line, you can see line 1, 2, 3. So once the cursor is on that line, you can just click run and it is just going to give you the answer. But once the cursor is not in any of the lines, then it's not easy to run any of the lines and get the result. So again, if you wanted to divide, so you take, say, 80 divide by 5. Again, you run that, you get that is 16. Now from here we can try to assign some values to certain variables. Say x, we use the less than sign with a dash, and we call this an operator, assignment operator. So this one is going to assign a certain value, say 4. So once you do that, if you highlight this and run it, you're going to see that it is down here, x is equals to 4, or because this again means x, you are assigning it a value 4, so you're saying x is equals to 4, and you can see it comes around this point. You can see x, then you can see 4. So that means that a variable x has been assigned a numerical value 4. Then let's say you assign another variable, say y, you assign it a value 6. Again, you run that. Once you run that, you're going to get it down here. So now if I wanted to get my x, so I can write x, highlight it, and then run. So you can see down here, it's going to give you the 4. The same case applies to y. So if I write y, then again you can see it's going to give me y. The value for y is 6. So that now I can work with x and y without working with the values 4 and 6, so that if I take x plus y, then I run that, then you can see that x plus y is equals to 10, because that is simply 4 plus 6, and that gives 10. If I take x multiplied by y and I run that, then I'm going to get 24. Now that means that 6, or rather 4 times 6 is equals to 24. And there is pretty much you can do with those values. You can divide, you can subtract, and so forth. Now, say for example, if you wanted to get some values, a sequence of values from say 11 to 30. So instead of writing 1 to 11, 12, 13, 14, 15, all the way up to 30, now RStudio can do this for you in a sprint of seconds. Say if you want values from between 11 and 30, so you can just write 11, then use the colon, then 30. So if I run this, then you can see down here I have 11, 12, all the way up to 30. So that is a sequence values between 11 and 30. So you can see it didn't require me to write all of them, 11, 12, 13, and so forth. Then again, I can also assign this, say s is equals to 11 all the way to 30. Now, so that if I now call my s, this one again is going to give me the same sequence down here, the same sequence down here. Now, say if I wanted now, suppose I wanted a sequence, but the difference between each value is say 2, 3, 0.5, and the like. So I'm going to introduce another function that you call the sequence. And so we can say now my new sequence will be s, or let's use a different letter. Let's say a is a sequence, so SA sequence. And you can see the good thing with RStudio is that once you start typing, it allows you to have some suggestions so that you can select any of those that you're interested with. But I'm interested with this function. So once you click on it, then you say 11. Then now here I'm going to put a comma, 30. Then I want my values between 11 all the way to 30. But between each value, the difference is 2. And so I put 2. Then I run this. And then I call my A. So you can see once I call my A, so now I have 11 down here, 11, 13, 15. So you can see the difference between any two values is 2. Now, say if I want, say B is a sequence of values, again between 11 and between 11 to 30, but the difference between each one of them is 0.5, and I run that. Then I call my B. So now you can see I have a total of 39 values. So because now we have from 11.0, 11.5 all the way up to 30.0, there are 39 values. And so that is the good thing with RStudio, or basically the R. So within a sprint of seconds, you can do a very huge task within few seconds, a sprint of seconds. Now, say if you wanted to create a sequence, or rather what we refer to as vectors, list of objects, say numeric objects, character objects, or logic objects, and so forth. Now we can create these vectors using a function C, whereby we say that we are concatenating. So here, let's say we want a vector to be the name, say to be the cat marks. So if I say cat is, so these are the marks of the cat. So say 22, 11, 26, 19 or 18, then 10, and then 15. So you can see I've created a list of numbers, and these are under one item, that is cat. And so if I run this, then I can get it. Now if I run that is the code. Now if I call my cat, then I can get the values here: 22 down here, 22, 11, 26, 19, 20, 10, 15. Now if I wanted to get any numerical summaries for this, I can easily get the mean of this. So I would say mean, then you can see it is suggesting for me what the mean that I want. So but I'm interested with the mean, so mean cat. So to just give me the mean or the average of these numbers, so the average of 22, 11, 26 all the way up to 15 is 17.16667. If I wanted the standard deviation, so I'll just say SD, then cut, and so it is going to give me the standard deviation as 6.306082 down here. You can see that. So you can see we're able to do a very huge task, but within seconds we're able to get that. Now again, we can do some so that is numeric. How about when you want to have a vector of a character? So say for example names. So we can say can call this class, and we say this class has these names of people. So with character we use the double quotation marks, and we say, can say we have John there, and comma, another one, and another one. So we say Jane, again comma, we say Jam, you can say another one, you can say Anne, you can add another one, you can say Mercy, and so forth. So if I run that code, then I call my class. So remember, I can also highlight it from this point. I can highlight just the name class, and then I run it. So it's going to give me all those names of the people in my class. Now that is about the vectors. How about when you want to create a matrix? Now remember again something else. When you want to comment in when you want to put a comment in RStudio, or you want to write a line that you don't want to again execute or run, so we use hash. So this one is going to tell us or to give us a comment of what is likely to be done in the next line. So create a matrix. So the RStudio is going to know that this is just but a comment, so it will not have any issues. But if you happen not to put this comment there, then you have problems. Now again, you should know that R is case sensitive. It is case sensitive. Say for example, if I wrote my class here, all these are small letters. But say for example, if I choose to write capital C, then class, and then I highlight this and run it. So you see, it's going to tell me that object class not found. The only reason for that is that this class here and this class here, they are not the same, because this one is small letter C, this one is capital letter C, and so it cannot run. So just like any other programming language, R is case sensitive. So whichever letters you use here, it has to be the same. It has to be the same when you're calling that say that object or item. Now we want to create a matrix. So I'm going to call my matrix M. So here we use a function matrix. So we say M is equals to, say, matrix, then my matrix is for values between 1 and 6. So I have 1 and 6. Remember again how we are able to generate these values, our sequence. So between 1 and 6, and then I want it to have 2 rows and 3 columns. So 2 rows. So this is how you indicate the number of rows that you want. So you can see it's giving you a suggestion here. So this can tell you the desired number of rows. So we say is equals to, so I want them to be 2 rows, then number of columns, so n columns. Again, you can see the desired number of columns, so we say is equals to 3, and we can run that, and then we can call our M. Once we call our M, you can see we have 1, 2, 3, 4, 5, 6. So we said we have it from n is equals to, our values are from 1 to 6, and we just want to be in column form. So this is a column Y matrix. So you start the column, so the first value goes in the first upper left corner, then followed by the second one. So these are the columns, and these are the rows. So the vertical ones are the columns, then the horizontal ones are the rows. Now say if we come up with another matrix, we call it W. We say W is equals to matrix, and this matrix is from 7 all the way up to 12. Then again, I want my number of rows to be 2, and number of columns to be again 3. So if I call this, if I call my W, you can see 7, 8, 9, 10, 11, 12, and I can basically do anything with these two matrices. I can add them. So we say we have M add to W, you can see it has added. So where you see where you have the first row first column, we have 1 here. First row first column, we have 7. So once you add the 2, you get 8. And you can see all through it's taking one value here, adding to the corresponding value here, and you get the answer there down here. So that is about. But now we can be more specific and say with our values, say if we can introduce another variables here and call this, say, p. We say p is equals to values from 1 to 3. Then we say q is a value, say between 10 to 12. So those are 3 values. So we can run this. You can also run this. And so if you run p alone, you can see p is 1, 2, 3. Q is 10, 11, 12. So we can form a matrix using this. So we can use 2 functions. One of them is cbind. Cbind means column binding, and so we can use the function cbind. You can see cbind and say p then q. So this is going to combine these 2 vectors to form a matrix, and they will be formed in a form of a column. So we will have column matrix whereby we start with, if it is p, we start with p values in a column, then q values. So here it is. You can see we have p. So p is 1, 2, 3, then q 10, 11, 12. Then we can use row binding. Here we use the function rbind. So we are going to bind it in the row form. So p then q. So if we run this, you can see now the p. So here now this is row. So p 1, 2, 3, then q 10, 11, 12, and so forth. Now that is just basically the basics of RStudio, things that you can do with RStudio. Now say if you wanted to work with some data, now RStudio has some data already in the, we have already some data here, such that if you call that data, say we have one of the data that we have around is the iris data. So this is a flower data, and if you call this, because this is already in inbuilt, this data is already fed into the system or into this program, and so you can easily call it. So say data, then you can say attach iris. Then you can see we can try to have a snapshot of what this data is about. So you can say head, then iris, and you can see down here we have this data for this flower. So we have the sepal length, we have the sepal width, the petal length, the petal width, and the species. So we have different flowers here. If you check tail of this data, so let's see. So you can see here now at the fine the tail, now we have Virginica. So here we had Setosa, here we have Virginica. So these are just species of flowers, but the data given here, you can see it is for the sepal length, then the sepal width, the petal length, the petal width. Okay, and you can see this can tell you that we have 150 flowers where data was collected from. And so from this you can easily do some again some summaries about this, whereby you can get, say, the mean. Say if you want the mean of the sepal length, so you can say mean of the sepal length, and you can see that is 5.8433. If you wanted the standard deviation, so that would be standard deviation of, again, the sepal. So again, you can see RStudio is giving you suggestions, so that is the standard deviation, that data. So we also have can also have another data again already previewed here, or already filled into the program, the data about cars. So you can say data, then cars, and then, so that means that you've already called this data now into the your script. Then you can say attach cars. Once you do that, then we can check what does this data contain. So get head, and you say cars. So you can see it's about speed and the distance covered, the speed and the distance covered. So all through check to the tail end of the cars data, you can see. So you have 50 cars with their speed and distance recorded. So this is basically some of the data that is already inbuilt here, and you can be able to again get some graphs for this. You can say you want to plot say the speed against the distance, because now the higher the speed, I think the higher or the greater the distance the car is going to cover. So you can plot this. So plot, and we are plotting the speed against the distance, and you can see here we have a graph here. This part, these on this left hand side, right hand side, we have the graph here. So the speed and the distances. So, and you can see as the speed, this can tell you as the speed increases, you can see how this graph is behaving. As the speed increases, the distance also increases. So basically that is a very nice and simple plot that you can get from RStudio. Now, say for example, if you happen not to want to work with this data, and you have some data possibly in Excel, and you want to work it or to do your analysis in RStudio. So how do you get that data into RStudio script? So we use a function. Use a function read dot table. So if your data is in tabular form, we also have read dot csv. So now this is if you are working with some Excel, and say for this one we are going to consider you have an Excel. So there are various arguments for this. So if I say my data 1, so I let my data 1, so that is the name that I'm assigning to my data, and I say read dot CSV. So you can see it is giving you suggestions. So read.csv. So now here we have some arguments. So you have file. So this is the name of your file. Header. So this is to tell us, or the logic to check whether your data does it have some headers, and if those headers are there, then it is going to consider them separate from the other values. Then how is it separated? Then we say it is comma separated. So CSV. So my data, so I'm going to check my data. So I have an Excel sheet that contains data, GDP per capita data for Kenya. So we can call that. So mine is saved in this form. So we have GDP per capita dot CSV. So that's the name of the file. Then I say header is equals true, and then separator, it's comma separated. So then I run that code. Now if I call this my data 1 and say let me not call the whole of it, so I can say attach data 1, attach data 1. So you can see it has been marked. So this can tell you that my data has 3 columns. You see down here you have red, so it has the column with the GDP per capita, then life expectancy, then year. So the year for each GDP and life expectancy. So if we check, let's check data 1, you can see you have the year, so this means it's from 1960. So then the GDP per capita, so this is 97. The life expectancy then was 46. Now let's see the tail this. So the tail of my data 1, and you can see now here this data is up to 2020, and you can see the GDP per capita has really increased from the initial around 90 to 1838. Again, you can see the life expectancy has also increased from the 46 to 66. Okay, and so now from this we can also plot and see, we can visualize this and see. We plot this, now we plot because now it's the GDP affecting the life expectancy. So if we plot GDP against the life expectancy, so you can see here, now here on this side, you can see we have the GDP per capita, then the life expectancy, and you can see as the GDP increases, again the life expectancy also increases. So there are a lot of things that you can do using RStudio and R. So if you want to learn more, please make sure that you subscribe to this channel. Again, you can leave your comment to tell us your experiences or ask any questions. You can like our video to recommend it to many more people, or even share. Then thank you so much. We meet in the next video. Bye bye.